Earth, our home planet, a tiny blue dot floating in the immense cosmic ocean. Here resides everyone you ever knew, every human who ever lived, every story that was ever told. It is where our journey begins. But as we zoom out beyond our atmosphere, past the moon, beyond the familiar planets and the sun, we embark on an epic quest. A quest to grasp the true scale of our universe, our nearest neighbor. As we leave Earth's embrace, the first marker on our cosmic journey is the moon, situated about 384,000 kilometers away. A distance so vast that if you were to drive a car at a constant speed of 100 kilometers per hour, it would take you over 160 days to reach it. Think about that for a moment. Over 5 months of continuous driving through the void of space just to reach our closest celestial companion. From this lunar vantage point, Earth appears as a fragile sphere of blues and greens, cradled in the black void of space. This perspective offers a humbling glimpse into our existence. The moon, Earth's constant companion for billions of years, has witnessed the entire saga of life on our planet. From its formation through cosmic collision to the present day, it has silently orbited our world, its gravitational pull shaping our tides, stabilizing our axial tilt, and creating the rhythms that life has adapted to over eons. The distance between Earth and Moon represents humanity's first real step into space. When Apollo astronauts made this journey in 1969, they traveled for 3 days through the void, becoming the first humans to witness Earth from another world. That journey transformed our understanding of our place in the cosmos. The photographs they brought back Earth rising over the lunar horizon fundamentally altered human consciousness and sparked the environmental movement. Here was proof, visible proof, of our planet's isolation and fragility, the heart of our system. As we continue our outward journey, the next milestone is the Sun, lying approximately 1 astronomical unit away from Earth. This unit, equivalent to about 150 million kilometers, serves as the standard measuring stick for distances in our solar system. The astronomical unit was born from necessity, a way to comprehend distances that dwarf anything we experience on Earth. Imagine this: light, traveling at an astounding speed of 300,000 kilometers per second, takes about 8 minutes and 20 seconds to journey from the Sun to Earth. This means when you feel the warmth of sunlight on your skin, you are experiencing energy that left the Sun over 8 minutes ago. If the Sun were to suddenly vanish, we would continue to see it shining for those final 8 minutes before darkness descended. If you were to travel this distance in a commercial jet flying at 900 kilometers per hour, it would take you about 19 years. 19 years of continuous flight just to reach the source of all energy that powers life on Earth. This immense distance is a stark reminder of the vastness of space, even within our own solar system. The Sun, a fiery behemoth containing 99.86% of all the mass in our solar system, provides life-sustaining energy to our planet from this incredible distance. The Sun itself is a marvel of cosmic engineering. Every second, it converts about 600 million tons of hydrogen into helium through nuclear fusion, releasing the energy that has sustained life on Earth for billions of years. This process occurs in its core, where temperatures reach 15 million degrees Celsius and pressures are so extreme that atoms fuse together, creating heavier elements and releasing tremendous amounts of energy in the process. The Red Planet. Venturing beyond our home planet and its solar companion, we set our sights on Mars, our enigmatic red neighbor. Mars, at its closest approach to Earth, is about 54.6 million kilometers away. However, this distance can stretch up to 401 million kilometers when the two planets are on opposite sides of the Sunday. This variation occurs because both planets follow elliptical orbits around the Sun, sometimes bringing them relatively close and sometimes placing them on opposite sides of our star. To put that in perspective, traveling to Mars at the speed of a commercial jet would take upwards of 50 years during favorable alignments, and much longer when the planets are on opposite sides of the Sunday. This vast expanse of space between Earth and Mars has been a significant challenge for space exploration. The rovers and probes we have sent to the Red Planet embark on a journey that is not just far, but fraught with complexities due to the constantly changing distances and orbital dynamics. Mars has captivated human imagination for centuries. Its reddish appearance, visible to the naked eye from Earth, sparked ancient civilizations to associate it with war and blood. In more recent times, as telescopes improved, astronomers observed what appeared to be channels on its surface, leading to speculation about ancient Martian civilizations and canal systems. Though these speculations prove false, Mars remains one of the most promising candidates for finding evidence of past or present life beyond Earth. The journey to Mars requires precise planning and timing. Mission planners wait for launch windows when Earth and Mars are favorably aligned, allowing spacecraft to follow efficient trajectories. Even with perfect timing, the journey typically takes between 6 to 9 months. During this time, spacecraft travel through the inner solar system, constantly adjusting their trajectory to intercept Mars at just the right moment. The margin for error is razor thin. A miscalculation of mere meters per second could result in missing the planet entirely. The ice giant's realm. As we journey to the outermost reaches of our solar system, we encounter Neptune, the distant ice giant lying roughly 4.5 billion kilometers from Earth. Neptune marks the edge of our solar neighborhood. Sunlight, racing across the vacuum of space, takes about 4 hours and 15 minutes to reach Neptune from the Sunday. This staggering distance showcases the enormity of our solar system. Neptune was discovered in 1846, not through direct observation initially, but through mathematical predictions. Astronomers noticed that Uranus was not following its expected orbit, suggesting the gravitational influence of an unknown planet. Using Newton's laws of gravitation, they calculated where this mystery planet should be, and when telescopes were pointed at that location, there was Neptune. This discovery stands as one of the greatest triumphs of mathematical astronomy. The planet itself is a world of extremes. Winds on Neptune reach speeds of over 2,000 kilometers per hour, the fastest planetary winds in the solar system. Its atmosphere consists primarily of hydrogen and helium, with traces of methane that give the planet its distinctive blue color. Deep within Neptune, beneath layers of gas and ice, scientists believe there may be a rocky core about the size of Earth, crushed under immense pressure. Neptune possesses a system of rings, though far fainter than Saturn's spectacular bands. It also hosts 14 known moons, the largest of which is Triton, a captured object that likely originated in the Kuiper Belt. Triton orbits Neptune in the opposite direction to the planet's rotation, a retrograde orbit that suggests it was captured by Neptune's gravity relatively recently in cosmic terms. This moon is geologically active, with geysers that spew nitrogen ice into space, creating thin atmospheric plumes. Humanity's farthest messenger. Launched in 1977, the Voyager 1 space probe represents humanity's insatiable curiosity and our desire to explore beyond known boundaries. As of now, Voyager 1 has traveled for over 4 decades, covering a staggering distance of more than 22 billion kilometers from Earth. It is the farthest human-made object from our planet, a silent wanderer in the cosmic sea. In 1990, at the suggestion of the renowned astronomer Carl Sagan, Voyager 1 turned its camera back toward Earth for one final photograph. This resulted in the iconic pale blue dot image. At a distance of about 6 billion kilometers from Earth, our planet appeared as a tiny, faint dot in the vastness of space. Sagan poetically reflected on this image, emphasizing our responsibility to cherish and preserve our only home, a small speck in the immense universe. Voyager 1 carries with it a golden record, a time capsule containing sounds and images selected to portray the diversity of life and culture on Earth. This record includes greetings in 55 languages, music from different cultures and eras, natural sounds like thunder and bird calls, and images showing human anatomy, architecture, and landscapes. The record was designed to last for billions of years, potentially outliving Earth itself and serving as humanity's message to the cosmos. The spacecraft continues to transmit data back to Earth, though the signals take over 21 hours to reach us, traveling at the speed of light. These signals grow weaker with each passing year, as Voyager moves farther away and its plutonium power source gradually decays. Eventually, perhaps in the next decade or so, Voyager 1 will exhaust its power and fall silent, continuing its journey as a derelict artifact of human ambition, drifting through the galaxy for millions or billions of years. The solar system's edge. At the very fringes of our solar system lies the Oort Cloud, a vast theoretical sphere of icy objects. This distant cloud is thought to extend up to a staggering 100,000 astronomical units from the Sun, that is about 1.9 light-years. A distance so immense that it stands on the cusp of interstellar space. Scientists determine the boundary of interstellar space, known as the heliopause. as the region where the sun's solar wind is stopped by the interstellar medium. This is where the influence of our sun ceases and the vast realm of interstellar space begins. The Oort Cloud represents the final frontier of our solar system, a boundary zone where the sun's influence wanes and the cosmic journey into the galaxy truly begins. The Oort Cloud has never been directly observed. Its existence is inferred from the trajectories of long-period comets that occasionally plunge into the inner solar system. These icy visitors are thought to originate from this distant reservoir, nudged from their frozen orbits by gravitational perturbations from passing stars, or tidal forces from the galaxy itself. When these comets approach the sun, they develop spectacular tails as their icy surfaces vaporize, creating the glowing displays that have fascinated humanity throughout history. The Oort Cloud is estimated to contain trillions of objects, most smaller than a mountain, but some potentially hundreds of kilometers across. These pristine remnants from the formation of our solar system preserve materials that date back 4.6 billion years, to the time when our sun and planets were born from a collapsing cloud of gas and dust. Studying these objects provides crucial insights into the conditions that existed during the solar system's infancy. Between Earth and our nearest stellar neighbor, there is a gulf of space so vast it challenges human comprehension. And if you've made it this far in our journey, consider taking a moment to join our cosmic exploration by subscribing to Broken Zach. Now, let us continue outward, beyond the realm of our sun, and into the vast ocean between stars, our nearest stellar neighbor. As we venture beyond the confines of our solar system, our next point of interest is Alpha Centauri, the closest star system to our sun, located about 41.3 trillion kilometers away. This distance is equivalent to over 276,000 astronomical units. At such colossal distances, the astronomical unit, a measure so convenient within our solar system, begins to lose its practicality. Hence, astronomers use the light year, the distance light travels in 1 year, for interstellar measurements. Alpha Centauri is about 4.4 light-years away from us. Considering our current space travel technology, a journey to Alpha Centauri is almost unfathomable. For instance, the Voyager spacecraft, traveling at about 17 kilometers per second, would take over 70,000 years to reach this neighboring star system. This immense distance underscores the vastness of space that separates the stars and highlights the extraordinary challenges of interstellar travel. Alpha Centauri is not a single star but a triple star system. The two main stars, Alpha Centauri, A and B, orbit each other in a binary dance, while a smaller red dwarf, Proxima Centauri, orbits the pair at a distance. Proxima Centauri is actually the closest individual star to our sun, at 4.24 light-years away. In 2016, astronomers discovered a planet orbiting Proxima Centauri in its habitable zone, where liquid water could potentially exist. This discovery ignited excitement about the possibility of finding life on the closest exoplanet to Earth. The space between stars is not truly empty. It contains the interstellar medium, a thin soup of gas, dust, and cosmic rays. This medium consists primarily of hydrogen atoms, with a density of about 1 atom per cubic centimeter. By Earth standards, this would be considered a vacuum far better than anything we can create in laboratories. Yet across the vast distances of interstellar space, this diffuse material adds up, playing crucial roles in star formation and the chemical evolution of galaxies. Our galactic home. Our journey now takes us to the grand scale of our home galaxy, the Milky Way. Spanning about 100,000 light-years in diameter, this vast spiral galaxy is home to hundreds of billions of stars, each potentially hosting their own planetary systems. Within this immense structure, there exists a tiny sphere known as the human radio bubble, extending about 100 light-years from Earth. This bubble represents the farthest extent of human influence in the cosmos, the reach of our radio and television broadcasts into space. Beyond this bubble, it is as if humanity never existed. Any civilizations residing in the vast majority of our galaxy would be oblivious to our presence, given that our signals have not reached them yet. The scale of the Milky Way is so vast that our entire recorded history is but a whisper in the cosmic wind, undetectable beyond this small bubble. Human civilization has been broadcasting radio waves into space for only about a century. These signals travel outward at the speed of light, forming an expanding sphere of electromagnetic radiation carrying everything from early radio broadcasts to television shows to communication satellites. This sphere, now about 200 light-years in diameter, encompasses only a tiny fraction of our galaxy. The Milky Way itself is a barred spiral galaxy, meaning it has spiral arms extending from a central bar-shaped structure. Our solar system resides in a minor spiral arm called the Orion Spur, located about 26,000 light-years from the galactic center. At this distance, our Sun takes approximately 225 to 250 million years to complete one orbit around the galactic center, a period known as a cosmic year. In the entire history of Earth, only about 20 cosmic years have passed. At the heart of our galaxy lies a supermassive black hole called Sagittarius A*, with a mass equivalent to about 4 million suns compressed into a region smaller than our solar system. This behemoth influences the orbits of stars near the galactic center, some of which hurtle around it at tremendous speeds. Observing these stellar orbits provided some of the strongest evidence for the black hole's existence, work that earned the Nobel Prize in Physics in 2020. The realm between galaxies. As we leave the Milky Way, we enter the vast, almost incomprehensible realm of intergalactic space. Here, galaxies float in the cosmic ocean, separated by mind-boggling distances. Our galaxy is part of a small cosmic neighborhood known as the Local Group, a cluster of more than 50 galaxies spread across approximately 10 million light-years. The Local Group is a diverse assembly, including not just spiral galaxies like the Milky Way and Andromeda, but also a multitude of smaller dwarf galaxies. The distances here are so vast that light from one end of the Local Group to the other would take 10 million years to traverse. This scale dwarfs anything within our own galaxy, underscoring the enormity of the universe. Intergalactic space is a silent expanse, a vast wilderness between the islands of galactic light. In this immense void, our galaxy, home to our entire history, is just a tiny speck among many, a single story in the grand cosmic library. The Andromeda Galaxy, also known as M31, is the largest member of the Local Group and the most distant object visible to the naked eye from Earth. Located about 2.5 million light-years away, Andromeda is actually approaching our galaxy at about 110 kilometers per second. In approximately 4.5 billion years, Andromeda and the Milky Way will collide and merge, creating a new, larger elliptical galaxy that astronomers have nicknamed Milky. Despite the dramatic nature of this galactic collision, the vast distances between individual stars mean that actual stellar collisions will be extremely rare. Instead, the two galaxies will pass through each other multiple times, their gravitational interactions stirring up stars and gas clouds, triggering bursts of new star formation. The supermassive black holes at the centers of both galaxies will eventually spiral together and merge, releasing tremendous gravitational waves that could be detected by future space-based observatories. The Local Group also contains numerous dwarf galaxies, many of which orbit the Milky Way and Andromeda like satellites. The largest of these, the Large Magellanic Cloud and Small Magellanic Cloud, are visible from Earth's southern hemisphere as fuzzy patches of light. These dwarf galaxies play crucial roles in understanding galaxy formation and evolution, as they represent building blocks from which larger galaxies grew through mergers and collisions over cosmic time. The Virgo supercluster. As we extend our cosmic gaze beyond the Local Group, we encounter the colossal Virgo supercluster, an immense collection of galaxy groups and clusters, including our own Local Group, encompassing a region of space about 110 million light-years in diameter, or 33 megaparsecs. The Virgo supercluster is a titanic structure in the universe. This supercluster contains thousands of galaxies from at least 100 galaxy groups and clusters, each with their own myriad stars and planets. At its heart lies the Virgo cluster, the largest concentration of galaxies in our cosmic neighborhood, containing over 1,300 galaxies. The gravitational pull of this massive cluster influences the motion of our Local Group and countless other galaxy groups within the supercluster. The Virgo cluster itself is dominated by the giant elliptical galaxy M87, which gained fame in 2019 when astronomers released the first-ever image of a black hole, the supermassive black hole at M87 center. This black hole has a mass of 6.5 billion suns and powers a jet of matter that extends 5,000 light-years from the galaxy. The image, captured by the Event Horizon Telescope, showed the black hole's shadow against the glowing disk of superheated material swirling around it. Within the Virgo supercluster, galaxies are not randomly distributed but arranged in sheets, filaments, and clusters separated by vast voids regions where very few galaxies exist. This cosmic web structure reflects the distribution of dark matter, the invisible substance that comprises about 85% of all matter in the universe. Dark matter's gravitational influence shaped the large-scale structure of the universe, pulling normal matter into dense regions where galaxies could form while leaving behind empty voids. Laniakea, our immense heaven. As we journey outward from the Virgo supercluster, we arrive at an even more staggering cosmic structure, the Laniakea supercluster. This immense congregation of galaxies, which includes the Virgo supercluster, extends over 500 million light-years and is our galactic home on a grand scale. Laniakea, meaning immense heaven in Hawaiian, truly lives up to its name. Containing the mass of 100 million billion suns, Laniakea is a gravitational masterpiece with galaxy clusters, superclusters, and countless celestial bodies bound in a cosmic web of attraction and motion. At the heart of Laniakea lies the Great Attractor, a mysterious region of space that exerts a massive gravitational pull on the galaxies within this supercluster. In this vast expanse, our Milky Way, the entire local group, and even the Virgo supercluster are just tiny components of this gigantic structure. Laniakea provides a profound context for our existence. In this immense supercluster, we are part of something far greater and more majestic than we can fully comprehend. The Great Attractor was discovered in the 1970 seconds when astronomers noticed that galaxies in our region of the universe were moving in a coherent flow toward a particular point in space. This anomalous motion could not be explained by the expansion of the universe alone. Something massive was pulling galaxies toward it. The Great Attractor is located about 150 million light-years from Earth, in the direction of the constellation Norma, but it lies behind the plane of the Milky Way, making it difficult to observe directly due to the gas and dust in our galaxy obscuring the view. Later observations revealed that the Great Attractor itself is being pulled toward an even larger structure called the Shapley supercluster, located about 650 million light-years away. This supercluster contains 25 times the mass of Laniakea and exerts an even greater gravitational influence on our cosmic neighborhood. These discoveries revealed that galaxies and galaxy clusters are not scattered randomly through space, but are organized into vast structures connected by invisible threads of dark matter. The mapping of Laniakea was made possible by measuring the peculiar velocities of galaxies, their motion relative to the expansion of the universe. By studying these motions, astronomers could trace the gravitational influences shaping galactic movement and define the boundaries of our supercluster. This work revealed that we inhabit a specific cosmic address: Earth, Solar System, Milky Way Galaxy, Local Group, Virgo supercluster, Laniakea supercluster, the observable universe. As we reach the boundaries of our cosmic exploration, we encounter the limits of the observable universe, an astronomical marvel stretching about 93 billion light-years in diameter. This begs a fascinating question. If the universe is only 13.8 billion years old, how can it be so vast? The answer lies in the nature of cosmic expansion. The universe has been expanding since the Big Bang, stretching space and increasing distances between celestial bodies. But this expansion is not simply objects moving through space. It is space itself expanding, carrying galaxies along with it. This distinction is crucial because the expansion of space is not limited by the speed of light. Objects sufficiently far away can recede from us faster than light travels, not because they are moving through space at superluminal speeds, but because the space between us is expanding. When we look out into the universe, we are also looking back in time. Light from distant galaxies has taken billions of years to reach us, so we see these galaxies as they were in the distant past. The most distant objects we can observe are seen as they were just a few 100 million years after the Big Bang, when the universe was young and the first stars and galaxies were forming. The cosmic microwave background radiation, detected in every direction we look, represents light that has traveled for 13.8 billion years, released when the universe was only 380,000 years old. At that time, the universe cooled enough for atoms to form, allowing light to travel freely for the first time. This ancient light has been stretched by the expansion of the universe from visible and ultraviolet wavelengths into microwaves, creating a faint glow that permeates all of space. But what lies beyond the observable universe? This remains one of the greatest mysteries of cosmology. Some regions of space are expanding away from us faster than the speed of light, placing them forever out of our view. Consequently, the true size of the entire universe remains unknown and is potentially infinite. The observable universe, vast as it is, might just be a tiny fragment of the entire cosmic expanse. Current theories suggest several possibilities for what lies beyond. The universe might be infinite in extent, with regions beyond our observable horizon containing more galaxies, more structures, continuing indefinitely. Alternatively, the universe might be finite but unbounded, curved back on itself like the surface of a sphere, so that traveling far enough in one direction would eventually bring you back to your starting point. Some theoretical frameworks propose the existence of multiple universes, a multiverse where our observable universe is just one bubble in an eternally inflating cosmos that continuously spawns new universes with potentially different physical laws and constants. These ideas remain speculative, as regions beyond our observable horizon cannot be directly observed or tested with current technology. The cosmic horizon represents a fundamental limit to our knowledge. As the universe continues to expand, this horizon changes. Paradoxically, while more light from distant galaxies reaches us with each passing moment, the accelerating expansion of the universe means that many galaxies currently visible will eventually disappear beyond our cosmic horizon, their light unable to ever reach us again. In the far future, billions of years from now, an observer in our galaxy would see a much lonelier universe, with only the galaxies in our local supercluster visible, all others having receded beyond the observable limit. The cosmic perspective. We are left with a humbling realization that there might always be regions of space, entire galaxies and wonders, that we will never witness as they retreat endlessly into the depths of the ever-expanding universe. Our cosmic journey has taken us from Earth, a mote of dust suspended in a sunbeam, to the largest structures in existence, spanning hundreds of millions of light years. Along the way, we have encountered distances that challenge human comprehension, from the 384,000 kilometers to our moon to the 93 billion light years across the observable universe. Each step has revealed the universe to be larger, more complex, and more magnificent than our ancestors could have imagined. The universe contains at least 2 trillion galaxies, each with hundreds of billions of stars, creating a cosmic population of stars that exceeds the number of grains of sand on all of Earth's beaches. Yet despite this vastness, or perhaps because of it, our small planet orbiting an average star in an unremarkable region of a typical galaxy takes on profound significance. We are the universe becoming aware of itself, matter organized in such a way that it can contemplate its own existence and origins. The atoms in our bodies were forged in the cores of ancient stars that died long before our sun was born, making us quite literally made of star stuff. This cosmic perspective carries with it responsibilities and possibilities. The recognition of our planet's isolation and fragility in the immensity of space underscores the importance of preserving our only home. At the same time, our ability to understand and map the universe, to comprehend structures spanning hundreds of millions of light years while standing on the surface of a small rocky world, reveals the remarkable power of human curiosity and intelligence. Future generations may push these boundaries further, developing technologies that allow us to explore interstellar space directly or detect signals from civilizations in distant galaxies. They may solve the mysteries of dark matter and dark energy, understand the ultimate fate of the universe, or even find ways to transcend the limitations that currently confine us to our small corner of the cosmos. For now, we continue our exploration through telescopes and space probes, mathematical equations, and computer simulations, each discovery adding another piece to the grand puzzle of cosmic existence. Every answer raises new questions. Every horizon crossed reveals further horizons beyond. This endless frontier of discovery reminds us that the universe will always hold mysteries, will always offer new challenges to our understanding, will always inspire wonder in those who dare to ask how big, how far, how much remains to be discovered. If you enjoyed this video, watch this one too. It's a great one. And with that, we'll see you in the next video.